Good evening. All right. Students, welcome back. WOC welcomes back all my dearest students for the day 2 revision. Yes. Yesterday I started with a chapter that's nothing but electrochemistry. Today we are going to continue with the chapter and we are going to see the detailed topic-wise discussion for board exams. Along with that, we are also going to do the MCQs, that is nothing but your numericals which are there related to that. Yes. Let us start off with the topic, students. Let's see on day 2 what are we going to study. So remember, we have day 1 session also. Please go through the video which is kept in the playlist. All right? All right. So let's start off with the topic. As I said, we are going to start with the chapter electrochemistry, which we did yesterday. Today, we are going to study the topics like electrode potential. Yes. We are going to study what is meant by EMF. Yes. We are going to also do the related numericals to that. Double S. Yes. Triple S. Right. Let's start off. First of all, when I have to talk about electrode potential, understand students? Okay, so before that, these are the topics which are prescribed by the boards for your 2022 boards. Yesterday, we have completed redox reactions, that is on day 1. All right, so today we are going to do what is meant by EMF of the cell, that is on day 2. This is also on day 2. We are going to do day 3, everything complete chapter. I will do it according to my pace, everything. All right, let's start. So first of all, these are also the topics which are prescribed for your syllabus. Please note it. Now, first let us understand what is meant by electrode potential or single electrode potential. All right. So first of all, electrode potential, simple word students, just check. Now this is a electrochemical cell, just your galvanic cell. Yesterday we have seen this. In this, you have a metal rod dipped in its electrolytic solution, correct? Zinc is dipped in its zinc sulfate electrolytic solution. So this is your electrode, that is your metal rod, which is your zinc electrode, and this is your electrolytic solution, which is their electrolytic solution. Same like that, you have copper electrode with the electrolytic solution, right? Important. Now, what is electrode? Now, basically, we very well know the first compartment is the anode electrode, anodic compartment, where always there is loss of electrons, correct? This is what we have seen yesterday. This is the cathodic compartment where there is always gain of electrons, that is nothing but reduction, correct? This is what we have seen yesterday. All right, now electrode potential is basically, if I have to define, let me take a different pen for you all. Yes, this is nice, black. All right, so I am defining electrode potential as electrode potential, basically, if I have to simply define, yes, it is a tendency. What is the tendency, students? Tendency of an electrode means what is the property of the electrode? What is the electrode doing? Either the electrode is losing electrons, yes, either it is gaining electrons. Okay, the tendency of the electrode to either accept, or first we will write lose. Okay, let us write lose. A tendency of an electrode to either lose electrons, or tendency of an electrode to either accept electrons. This is called electrode potential. For example, if I take oxidation reduction or oxidation electrode potential, right? Here what is happening, students? Zinc is losing 2 electrons and is forming Zn plus 2 electrons, correct? Now at the same time, if I take reduction, okay, copper is taking those 2 electrons and becoming copper metal, correct? Na copper solid rather, right? Now here observe the electrode potential difference, right? Now this is what is electrode potential. Now the difference between your oxidation, or the difference between your, I'll make like this, the difference between your metal strip and solution is called electrode potential. What is that, students? The difference between the metal strip and your electrolytic solution is known as half cell electrode potential. Let us write. So this is the basic electrode potential difference, basic. And when I have to write the actual thing, let us write what is meant by half or cell electrode potential. If somebody asks you, just write. It is denoted by an alphabet that is nothing but capital E. Okay, right. Now, what is this? It is we will write the electrical potential difference. The electrical potential difference between what students? It is nothing but the metal strip which is there, metal strip, that is your zinc metal strip or the copper metal strip, and its solution, that is nothing but the electrolytic solution. That's all. This is called electrode potential or half cell electrode potential. Easy. Okay, now we said there are two things happening: oxidation is happening, reduction is happening. So remember, if let us make this as first point, let us make the second point. Remember, in this particular cell, if the oxidation process or the tendency of oxidation is happening here, oxidation, correct, anode oxidation, correct, cathode reduction. Now remember, if somebody asks you what is meant by oxidation potential, means observe carefully. Basically, oxidation potential means same thing. I'm going to denote with EOP. EOP. What is this? It is tendency of oxidation, means tendency of losing electrons. So oxidation potential is tendency of oxidation, that is nothing but loss of electrons, correct? Right. Okay, now this potential difference between the metal strip and its solution. So basically in this case, what is this? This is zinc or copper, and here it is the electrolytic solution, zinc sulfate or the copper sulfate, correct na? All right. So tendency of oxidation, that is nothing but loss of electrons, that is oxidation potential. Third one, same, I'm going to write as reduction potential, nothing but it is also called as ERP. ERP. What is it, students? It is same story again. Tendency of reduction, that is oxidation. This is tendency of reduction, that is nothing but gain of electrons. Easy. Okay, easy. Now remember, always. So when I talk about oxidation potential and reduction potential, simple as that. Simple as that. Just check. Both the things are the same. Both the things, whatever are happening, are the same. So basically, oxidation potential is same in magnitude. Okay, same in measure, same in magnitude with reduction potential. It is same in magnitude or measured, but opposite sign is used. So only thing is opposite in sign to its reduction potential. Okay, opposite to sign of its reduction potential. Okay, now what is this, ma'am? I didn't understand. That means always remember, ERP is equal to EOP. Okay, we are going to standardize it to the RP, reduction potential values. We are going to standardize and do all the numericals. Okay, so if, better we will understand more. Okay, let us understand more. Let us take one example. See here, zinc solid is getting converted to Zn plus 2 plus 2 electrons. This is an aqueous medium. Now, this is loss of electrons, no students? Yes, where does this happen? This happens, or this particular thing happens with a negative electrode. Okay, negative electrode is nothing but anode. Okay, and now as we know, zinc is a negative electrode. What happens here? There is always loss of electrons, correct? That means oxidation is happening. So here at this particular electrode, we call this as oxidation potential. How much is this value? This is almost, just check here, 1 molar zinc sulfate solution happens at what? At 298 Kelvin, the standard conditions. The oxidation potential was, because it is oxidation potential, I'm writing it as plus 76 volts. Is it understood, students? This is the condition of oxidation potential at standard level. Same thing if I'm going to write about reduction potential, check carefully. Same zinc I'm taking. Yes, now this zinc is trying to accept 2 electrons and is going to become zinc solid. This is single electrode potential, no problem. Here what is happening, right? This is happening at the positive electrode, and I'm calling this as reduction potential, got it? All right, now here what is the condition? 1 molar zinc sulfate at 298 Kelvin. Okay, how much is the reduction potential? It is nothing but 0.76 volts. Okay, now you're able to see the difference, students. The difference here in both the cases is only the sign convention. Got it? only the sign convention. So simple. So when your teacher or somebody asks you, okay, what is meant by, now electrode potential is clear, oxidation potential is clear, reduction potential is clear. Now important thing, we have to learn about a concept called standard electrode potential. Okay, standard electrode potential. Okay, what is standard electrode potential denoted by? It is denoted by a word called SEP. S, capital E, capital P. All right. Now, conditions for when do we calculate standard electrode potential? Remember, the concentration of the particular electrolytic solution should be 1 molar. Means 1 molar concentration, or if let me write full term, full sentence, 1 molar concentration of the ions. Okay, this should be the concept. After that, what should be the temperature? The temperature maintained is 298 Kelvin. Okay, what should be the pressure? Pressure should be 1 atm pressure. Okay, 1 atm. All right. Then when these conditions are maintained, I call, or when I calculate that, I call that as, or this particular condition, and the potential which we calculate is called as standard reduction potential. So this, when at these conditions, what do we call that? We call it as standard reduction potential. We said no, IUPAC asked us to take only, consider only one term, students, that is that is nothing but RP. Don't get confused by OP, RP. Take RP, only sign convention you will change. So what is it denoted by? E naught. Okay, all right. So always remember, RP is equal to minus OP. That's all. Remember this value, easy. Clear, students? Okay. Now remember, this standard reduction potential is of two types. For oxidation, it is called SOP. For reduction, it is called SRP. Easy? That's all. Let me drink some water. All right, done. So this is your electrode potential and standard electrode potential. Now let us see one more word, that is nothing but EMF of the cell. Before that, remember one thing. What did we study? Let us do one summary till now. Let us do one summary. We studied what is the definition of electrode potential. Done, students? We did this. Okay, just now we have done this. Okay, done. After that, I've taught you what is meant by, or I have given you what is meant by electrode potential difference, rather, right? Correct. I asked you what is, I have also defined what is meant by half or cell electrode potential. Correct na? Cell electrode potential, this is denoted by which alphabet, students? This is denoted by E. Correct? Yes. Okay. Then I have taught you what is meant by oxidation potential. Along with that, I have taught you what is meant by reduction potential. I've also taught you what is meant by SEP, standard electrode potential. I've also taught you what is meant by SOP and SRP. Then I gave one word to remember, RP is equal to minus OP. This is what we have given the difference. Now, let us define what is meant by electromotive force. Okay, simple, students. See here, electromotive force is the potential difference between two terminals. Okay, when do we calculate electromotive force? When no current is drawn from it. Yesterday we have seen the cell reactions also, no? So there is no current. The cell completely, it is over. The complete transfer of electrons from anode to cathode, current from cathode to anode, everything is complete. Now no current is flowing from that. And how do we measure? We measure it with a potentiometer or vacuum tube voltmeter. Okay, so electromotive force is a force or the EMF when no current flows to the cell. How do we calculate? Basically, we write EMF of the cell as E cell, or we can also write it as EMF, which is given by, yes, remember, reduction potential, that is nothing but your cathode minus ERP. Always consider in terms of RPs only. Okay, yes, or you can write like this, E naught, this is for the standard EMF of the cell, or EMF naught means it is at standard conditions, E naught RP cathode minus E naught RP anode. Easy, easy, students. That's all. Easy. So this is your EMF of the cell. Now Using this concept, let us apply the or solve the MCQs. Let me check whether it is getting recorded or not. Okay, it is getting recorded. Let's see. It is getting recorded. All right. Let us just jump into the MCQs with the numericals. Right. The tendency of an electrode to lose electrons is what? Oh, easy. To lose electrons, oxidation potential. Whenever some metal, if I put like this, whenever some metal loses electrons, it is called anodic reaction, anodic half cell reaction, or it is nothing but oxidation potential. So the potential difference between the metal electrode and its solution, electrolytic solution, is called oxidation potential. Easy. So the answer is that. Next, the electrode potential depends upon it is all it depends upon temperature, nature of electrode, concentration, all of these. Okay. Next question. In a galvanic cell, current flows from. Oh, easy, now, students. Always remember, in a galvanic cell, electrons always flow from anode to cathode. Electrons. From cathode to anode, current flows. Got it? So they asked me current. So current flows from cathode to anode in the external cell. Why? Here, important thing, cathode is at the higher electrode potential. Higher electrode potential. Anode is at the lower electrode potential. That's why the electrons are flowing from lower to higher and current from, because the potential is very high, no? That's why current flows from cathode to anode. Okay, next question. EMF of a cell in terms of reduction potential of its left and right electrode is, okay, we very well know right minus left, because in an electrolytic cell, this is an anodic compartment, and in an electrolytic cell, this is a cathodic compartment. Both are connected by a salt bridge like this, and both the electrodes are again connected this way. Correct, no, students? Yes, right. So this is what the diagram is very vague. Sorry for that. So this is your left compartment. This is your right compartment. Cathode minus anode. Next. The standard electrode potential of E naught for half cell reactions are given here. Okay, let me see. I have a page. I have a page. Let me do the sum. Okay, sorry. Right. Now check here. First, zinc is losing electrons. So what is electrode potential? This is oxidation potential. Correct. Now iron is gaining. What is happening here? Oh, here iron also is losing electrons. Correct. This is also oxidation potential only, correct? But what should I write? I have to write everything in terms of reduction potential, correct, now, students? So what will I do? What will I do? I'm going to change the sign convention. Just check here. This 0.76, I'm going to write it as minus 0.76. Why? We've already learned RP is equal to minus OP. Correct na? So I'm going to make this as minus 0.76. 0.41 I'm going to convert into minus 0.41. That's all. Easy. All right. So EMF of the cell they asked me. So what is EMF of the cell? EMF or the E naught cell rather. It is nothing but cathode minus anode. Correct? E cathode minus E anode. Let me do in the next page. So how much is the cathodic compartment, students? Cathodic compartment. All right. Reduction potential. It's nothing but EMF of the cell is equal to minus 0.41 volts minus of minus 0.76 volts. Which is the answer? E naught cell, at standard is equal to nothing but it is okay. It is plus 0.35 volts. That's all. So what is the option left? Option okay. Option is B option. Easy. Let us see the next question. Oh, big question. The standard electrode potential of zinc and silver in water at 298 Kelvin are so much. Okay, values are given to me. Right. Which of the following actually takes place? Okay, now understand carefully. Let us see which is oxidation, which is reduction. Observe, students. Here in this case, first one is oxidation potential. Correct? Oxidation potential. Right. In the next case, it is nothing but given as minus. Given as minus, just opposite. It is opposite sign, that's all. This is reduction potential. So when I cancel the electrons, so basically how is this happening? Zinc from solid, it is combining with, see here, two electrons, no, two silver aqueous, right, forming Zn plus 2 ion, which is in aqueous form, plus 2 Ag solid. This is what is happening, students. Yes, 2 I have written, so 2 electrons, correct. So when I compare which of the reactions are happening, just check. This is nothing but a reaction A, because first K is OP, second K is RP. I have written both the reactions and checked. Next. The cell reaction of a cell is this. Okay. Magnesium plus copper gives me copper plus magnesium. Okay. What is it? If the reduction potentials of magnesium and copper are given. Okay. What are given? Magnesium and copper. So for magnesium, always this is oxidation potential, because it is losing electrons. No? From magnesium, it is going to Mg plus 2. So 0.23 is which one, students? This is oxidation potential. Copper from plus 2, it is going to 0. Correct? This is a reduction potential. So this particular thing is Rp. That's all. EMF of the cell, easy. E naught cell is equal to E naught cathode minus E naught anode. That's all. Do I have a page back? No, I don't have. I'll do it here only. So E naught cathode, what is that? It is nothing but reduction potential cathode. This is oxidation potential. This is anode. Subtract that, right? 0.34 minus of minus 2.37. How much is the answer? Yeah, the answer will come around plus, okay, it will come around 2 plus 2.71. Take it. Easy. One more sum. Electrode potential of zinc plus 2 and zinc is 0.76, minus 0.76. Okay. So this is minus 0.76. Which reaction is this, students? This is nothing but your oxidation potential. Oxidation potential, which is happening at the anodic compartment. Okay. And that of copper is plus 3, 4. This is nothing but cathodic compartment. So they're asking you to find easy cell, easy reaction. E naught cell is equal to E naught cathode minus E naught anode. Okay, how much is the cathode? Plus 0.34 minus of minus 0.76 volts. Kitna aaya? When I subtract 1.1 volts. Which 1.1 volts? Careful, positive. So, easy. Next question. For the electrochemical cell, this is one cell reaction given to us. Okay, right? They have given me for the electrochemical cell M plus to M. How much is the electrode potential? 0.44. And E naught cell for X to X minus is 0.33. Okay. First of all, let us write what are they asking me from the data. Deduce whether the reaction is spontaneous or not. Okay. Let us first understand the concept and write. First of all, let me make my LHS side. I'll make this as oxidation potential. I'll make like this. Okay, right? Then RHS I'll make this as reduction potential. I'm writing little bit reduction potential. This is also fine. Okay, done. Now, LHS side, what happened? Metal has got converted to M plus 1 electron. How much is electrode potential here given to me? 0.44. Okay. Here, in this case, X is taking that electron and is forming X minus. How much is electrode potential value here? It is 0.33 volts. Done. This is what is the thing. Now, let us take this as equation 1. Let us take this as equation 2. Combine both M plus, let us write both M plus electron, X plus electron and X minus. Electron gets cancelled. How much? What is left? M plus X gives me M plus X minus. Correct, my students? That's all. So let me take one eraser and erase this so that it is not confusing you. Easy enough, right? That is what is the concept now. Just check. Here, important thing here is they asked me to calculate the feasibility of the reaction. So, let us take the reaction E naught cell is equal to E naught cathode minus E naught anode. This is what they've given. Cathode kitna aaya? It is 0.33. Anode kitna? It is plus 0.44. How much did you get? It is minus 0.11 volts. Okay. Now, I have got E naught cell value as minus. Remember, students, remember this, whenever your E naught cell values are negative, shall we write in the next page? Oh, no, please. No, please. So, whenever E naught cell values are negative means the cell reaction is non-spontaneous. The cell reaction is non-spontaneous. It is non-spontaneous. It will not happen. So what should we do? Let us go back to the option and mark it. So which reaction is the students? It is B. All right, it is B, non-spontaneous reaction. Okay, so the reverse side, the reaction I have written. So here this is the what did they give? Okay, this is wrong. Now they've given spontaneous reactions, which should be the reaction. Okay, let us not mark here because both are spontaneous. They have given. What did I get, students? I have got what? M plus X giving me M plus X minus. Okay, so I have to go M plus X. So I have got which reaction? I have got the first reaction. So this should be non-spontaneous option here. Clear? Okay, so let us take out that because the option given here is wrong. So I'm going to mark this as first one and then non-spontaneous reaction. See? Chalo. Next question. The standard electrode potentials of zinc plus 2 and zinc and silver plus and silver are. Alright, they have given the values here. What should I calculate? I have to calculate standard potential. Easy. E naught cell is equal to E naught cathode minus E naught anode. Easy. Cathode minus E naught anode. Okay, check. Which is cathode? In the first case, this is your oxidation potential. This is your reduction potential. Correct. So I'll be taking that as cathode 0.799 minus of minus 763, which is nothing but 1.562 positive value. You see? That's what. So, next question. Standard electrode potentials of silver by Ag plus by Ag and copper plus by copper is given here. Okay. Respectively. These electrodes are joined together by salt bridge. Alright. They're asking what happens. What is the condition here? Okay. Now, first of all, let us see which is oxidation potential and reduction potential. Okay. The first one, whatever is given to you, observe carefully, students. Silver plus by silver. This is nothing by reduction potential plus this is nothing but oxidation potential. Why? Let us see the reaction. See here. First of all, copper is losing 2 electrons rather. Yes. And giving me copper plus 2 electrons. Correct. Silver is taking, I'm picking up for 2 electrons. So 1 electron, you can write it as 1 also. Picking up 1 electron, making silver. Now what is happening? In this case, a reduction is happening. In this case, oxidation is happening. Correct, na students? That is why I have taken copper one as the oxidation potential, second one, and first one as reduction potential. Okay, got it? Let us solve now. E naught cell is equal to cathode minus E naught anode, and let us note that, right, check, 0.80 minus 0.34 volts. Yes, which is nothing but plus 0.46 volts. That's all. Easy. So the option here, what is the answer we have got it as? We have got this copper electrode. It is plus 0.6 volts. Okay, sure. Let us see one more question. More and more perfect you'll become. Okay. So basically for the cell reaction, okay, for the cell reaction, Cerium plus cobalt gives me 2 cerium plus 3 plus cobalt plus 2. Okay, calculate E naught cell. Same story, write the cell reaction. In the case 1, cobalt is getting converted to CO plus 2. What is this? Loss. So, oxidation potential, whatever is given there. Okay, how much is given here? Oxidation potential, it is nothing but 0.28 volts. Cerium from plus 4, it is gaining one electron and forming cerium plus 3. This is the reduction potential. How much is given? 0.19 volts. That's all. E naught cell is equal to sorry, cathode minus anode. Cathode minus anode. So how much is given, students? It is nothing but 1.89 minus 0.28 volts. How much is it? Uh, plus 2.17. Easy? Easy. So that is how one more. Let us see one more question and check. Next question. EMF of a cell whose half cells are given here. Okay. Below is they have given the half cell reaction with the electrode potential. They're asking me find the E cell, right? Same story. Which is this one, students? Magnesium to magnesium plus 2 electrons. Okay. So basically when I have to take this, observe. So this particular thing I have done yesterday's concept. So will you all try for your homework? Yes. Will you all try for your homework and tell me what is the answer? Yes, students. So check and tell me, try. Yesterday I've given you a clue also. I practiced now. Try this as a homework and tell me your answer in the comment section. Tell me the answer in comment section. So the student solve it, comment section. The students whoever gives me the correct answer, the name will be pinned. Okay. All right. Very good. So thank you so much, students. I'll be coming back with day 3. That is nothing but we are going to do Nernst equation. Yes, we will do Nernst equation and related numericals. Okay. Chalo. Meet you all again. My request is please like, please share, and please subscribe to the channel. I'm always, WOC is always going to be with you, students. Yes, so always stay happy. God bless you. I'm waiting for your answers. Stay happy. Yes, take care. I'll meet you again tomorrow.